This is a calculus free response problem, and this is kind of a classic problem. And I don't know if you can see one on this test on May 9th, but based on past history, you can see one like this. It's a calculator problem, and we're going to use the Nspire CX calculator. Let R represent the region bounded by y equals sine x, and y equals x to the fourth power. Find A, the area of R, B, the volume of the solid when R is rotated about the x-axis, and C, the volume of the solid when R is rotated about the y-axis. So the most important thing is to take a look at what this area is, and then find the intersection points so we can find our limits of integration. So to do that, we'll go to our TI Nspire CX calculator here and put in the two functions, one of which is sine x, and the other one of which is, now to get the second one, I press tab again, and we have x to the fourth power. And so we're going to have this little area here in quadrant 1 right close to the origin. And to take a closer look at it, I'm going to go to Menu, Window Zoom, and when you're actually taking the test, it's not going to be as crucial for you. I'm going to go from x equals 0 to x equals 1.5, and tap down here, y equals 0 to y equals 1.5, just to get a better look at the situation. So we press that, and here we have this area between upper bounded by the blue curve and lower bounded by the red curve, and this is our intersection point. And to find this, we're going to go to Menu, Analyze Graph, and we're going to go to For Intersection. And the first thing we see in the lower left corner of the view screen is lower bound, so we go to the left side and press Enter, and then it says upper bound question. We go to the right side, and it gives us an intersection, and it gives us coordinates. The x-coordinate 0.95, y-coordinate 0.813. The problem is we do not have, in our AP test, we need to have answers to at least 3 decimal places, which means for a preliminary answer, which we need to get for our limits of integration, we need to get more than that. Now, what I'm going to do is easier for you to do with your own calculator than it is for me to do here, but I'm going to take the cursor and hover over that x-coordinate, and then I'm going to press the plus sign on my calculator, and that gives me more significant figures. I do the same thing for the y-coordinate. Hover, I have an open hand, and press the plus sign several times, and here we have a xy coordinate out to 7 or so decimal places. And my recommendation is to take the first 5 or so decimal places in, and so we're going to have 0.94962 for x-coordinate and 0.81319 for the y-coordinate. Why 5 if we only need 3 for a final answer is because errors multiply as you go further. So anyway, I'm going to go over here and write these down, and we have our coordinate here, coordinate pair out to 5 decimal places. So I'm going to put 0.94962, and for our y-coordinate 0.81319. Okay, so that's what we're going to look at. And so for A, our area, working this out, we're going to have the integral from 0 to our x-coordinate intersection point, which is 0.94962, and we're going to have this top function, which is the sine, So we'll just say sine x minus x to the fourth power dx. And we get most of our points right without even pressing a calculator button, because we have identified the intersection point. We have set up our integral properly, so all that's remaining to do is go to our calculator, and to get to our calculator, what we need to do is get another page, and we're going to add calculator, and a shortcut to get the definite integral is to go shift plus sign, and our lower limit of integration is 0. Our upper limit is going to be 0.94962, and over here we're going to have sine, and we don't really have to put this in parentheses, I believe, and so we have sine x, and we come out here minus x to the fourth power now, and then dx. And our problem is that we're in degrees here, and we really need to be in radians. So that's one thing to look out for. I'm going to go to menu again. Excuse me, on here. Settings. I should have looked at that first. Go to document settings. Let me go to radians and tab down here. Press OK, and we should be good to go here. And yes, we are in radians. So another time, shift plus 0 to 0.94962. And then we come here and put sine x minus x to the power 4 and dx. And we have three decimal places. We put 0.264. Now they'll actually give you credit for 0.263, but rounded properly, I'm going to say 0.264. So here we go. Now, one thing that will happen if you actually are in radians and you have a negative number, let's say that you subtract out, instead of you put x to the fourth minus sine x, and you get a negative 0.263. What you can do is you can just put absolute value brackets and kind of correct your error that way. Okay, so that's answer to A. For B, what we're going to do is take this area here. I'm going to draw a rough sketch here. There's the x to the fourth. Here's the sine. So we're going to take this area here and rotate it around the x-axis. Okay, that's going to be our next thing here. And to do that, what we have is the setup is just the same as the first to begin with. We have 0 to 0.94962, and then we have pi, and we have our outer radius squared. So we're going to have sine squared x minus x to the fourth squared, so that's going to be minus x to the eighth, and that's going to be dx. And again, you get most of your points for just having it to this level here, okay, without even pressing a calculator button. So, but we now go to the calculator, and we enter, you see we're in radians still, we enter pi, and we go to get our integral, definite integral by pressing shift plus sign, and the limits of integration are still the same, 0 to 0.94962. Oops, put it up here. 0.94962. And then down here, I'm just going to put it in parentheses here. We have sine x, and we're going to square that, minus x to the power of 8 dx. Press enter, we get the 3 decimal places 0.529. Okay, so we go here, 0.529. Now, part C, about the y-axis. We're going to take this area here, same area, but rotate it this way about the y-axis to create that rotation of solid. So what we're going to have to do is get these equations in terms of y, and we're going to have this x to the fourth minus this one here going this direction. So what that's going to do is going to change our limits of integration. It's going to be pi again, but instead of going from 0 to 0.94962, we're going to go up the y direction to 0.81319. And then we have to take the top function, which is x to the fourth, minus this one here, which is going to be, let's see, we're going to look at in terms of y. So what are the functions going to be in terms of y? Well, what we're going to have is, if we put y equals x to the fourth, if we take the fourth root of both sides, we're going to solve for x. So we're going to have x equals plus or minus the fourth root. It's fourth root of x. And then we're going to, so that's going to be this one here. And as far as the other function, we're going to have y equals sine x. Well, to solve for x, we're going to take the inverse sine of the whole equation. So what that means is that x is equal to the inverse sine of y. So that's the one we're going to subtract. So what we're going to have is fourth root of x squared minus the inverse sine, let's see, that's of x squared. It's going to be of y. Y is your input here. Okay. confusing the heck out of my viewers, okay? And so that's going to be y here, right? And an inverse sine of y, and we're going to be squaring both of those, and then we're going to have dy out here. And so this fourth root, the square, is going to be the square root when you take care of it. So we can go back to our calculator and put in pi. Okay, pi. We'll go shift plus 0, this time to 0.81319. And we're going to have we had the fourth root squared, so it's going to be the square root. We'll just put it for x instead of here. And then we go out here, and we're going to put minus. And I think that's okay. I'm going to make parentheses here for sine, for inverse sine, excuse me. Press trig button, inverse sine x, and we're going to have to square that. We got to go one more to square it. Yeah, and then dx. Make sure everything is right. Yeah, it should be that. So we get 0.86. Looks like 0.869. So we come here. So these are our answers. Again, of these 9 points possible, only 3 of these would be for the actual number calculated correctly. Everything else is going to be in the setup. Good luck on all your problems, and as always, thanks for viewing.